1 minute.
Sir, you're on mute. Hello, sir.
Sorry. Actually, sorry. See here. Now I'll start the resonance. Actually, series RLC resonance. In your syllabus, we are having series RLC resonance. I think we had, the series RLC circuits. 1 minute, I'm projecting the video. One minute, I'm setting. Okay, listen here. First, draw the circuit, RLC circuit. This is R, L, and C. V and F. This is the RLC circuit. Can you tell me the impedance of this circuit? Can you tell me the impedance of this circuit?
R minus
R plus J into
XL minus XL.
XL minus XC. This is the impedance of the circuit. Now, resonance will occur when XL is equal to XC. Madam, note point. Resonance will occur when XL is equal to XC. Madam, resonance will occur when XL is equal to XC. When inductive reactance is equal to capacitive reactance. When inductive reactance is equal to capacitive reactance, resonance will occur. Please note down. Resonance will occur when inductive reactance is equal to capacitive reactance. What is the inductive reactance?
Omega.
Omega. What is XC?
By omega.
1 by omega C. Now here I am taking it as omega naught. Omega naught I am taking on both sides. Here omega naught square is equal to 1 by LC. Sorry. Omega naught square is equal to 1 by LC. Bring this omega to the square root to this side, square to this side. It will become 1 by root LC. This is equation 1. We have to remember this equation. Omega naught is equal to 1 by root LC. Omega naught is equal to 1 by root LC. Now I want resonant frequency. Omega naught is 2 pi f naught 1 by square root of LC. F naught is equal to 1 by 2 pi root LC. This is the resonant frequency. Remember the formula for resonant frequency. F naught is equal to 1 by 2 pi root LC. You have to remember this formula. Resonant frequency F naught is equal to 1 by 2 pi root LC. So when resonance will occur? At what condition?
XL equals to XC.
When XL is equal to XC, we'll get the resonant condition. This is the resonant condition. This is the resonant condition. And resonant frequency is F naught is equal to 1 by 2 pi root LC. Okay. Now here, now I will draw the curve. This is the series RLC circuit. For the series RLC circuit, resonance will occur when XL is equal to XC and resonant frequency is this one. Now I will draw the curve for R, XL, XC and Z. For what I am drawing the curve? For R, for XL, for XC and Z. I will draw the curve, resonant curves. Resonant curves I will draw. Now see here. Z is equal to R plus J XL minus XC. Now first I am taking XL. What is XL formula?
Omega L.
Omega L. Omega is 2 pi F. That means XL is proportional to F. XL is directly proportional to F. Now here on y-axis, on x-axis I am taking F naught. Sorry. I am taking frequency. On the x-axis, I am taking the frequency. 1 second. On x-axis, I am taking the frequency. On y-axis, I will take one second. And next I will take frequency. 1 second. On y-axis I will take R, XL, XC and Z. On y-axis I will take R, XL, XC and Z. First I am taking XL. XL is directly proportional. Suppose if F is equal to 0, what is XL? If F is equal to 0, what is XL?
0. 0.
0. XL is 0. Suppose if F is increasing, automatically XL is also increasing. It is directly proportional. If it is directly proportional means like this it will increase. This is XL. This is your XL. If F is increasing, your XL is also increasing. Linearly it is increasing. Linearly it is increasing. Suppose if F is equal to 1, XL is also 1. See here. If F is equal to 1, XL is also 1. Join these two, it will intersect here. If X is 2, F is 2, XL is also 2. 2 means here. If you join all these points, you will get linear curve. If you join all these points, I'll get the linear curve. So this is your graph for XL. This is your graph for XL. Okay. Next I will go for XC. Next I will go for the XC. This is XL. Next XC, you see, XC is equal to 1 by omega C. XC is inversely proportional to frequency. That is equal to 1 by 2 pi FC. XC is inversely proportional to frequency. Now substitute F is equal to XC is equal to, take it as 1 by j omega C. If j comes to numerator, it becomes minus j. XC is proportional to minus 1 by F. XC is proportional to minus 1 by F. Because 1 by j omega C, let us take 1 by omega C actually formula. Here j is denominator. If j comes to numerator, it becomes minus j. XC is negative. XC is negative. If XC is negative, substitute F is equal to 0. What is 1 by 0?
Infinity.
Infinity. Minus infinity. Minus infinity means on y-axis. I am taking minus infinity somewhere. Here I am taking minus infinity. Let us take somewhere. It goes beyond this. We can't define the infinity. It goes beyond this. Minus infinity. Now let us take F is equal to infinity. What is F is equal to infinity? 1 by infinity.
0. 0.
0. That means when F is equal to 0, your XC is minus infinity. When F is equal to infinity, your XC is 0. 1 by infinity is 0. That means your curve will vary from minus infinity to 0. See XL. For XL, if F is 0, XL is 0. If F is equal to infinity, what is XL? What is XL?
Infinity. Infinity.
Infinity. That means your XL is varying from 0 to infinity. Your XL is varying from 0 to infinity. But your XC is varying from minus infinity to 0. Minus infinity to, at infinity it will be 0. If F is infinity. When F is 0, it is minus infinity. When F is infinity, it is coming to 0. It is coming to 0 like this. At infinity, it will touch the x-axis. It is 0. It will touch the 0. This is XC. This is XC. Any doubt in this XL and XC?
No, sir.
Okay. Now see here. Now I am taking resistance is depending on frequency.
Yes, sir.
Resistance is No, resistance is not depending on the frequency. Resistance is constant. Resistance is constant. There is no XL is equal to omega L. In the formula, frequency is there. XC is 1 by omega C. Resistance is independent of the frequency. Suppose if R is equal to 10 ohms, it will be constant throughout the. This is the curve for the resistance. Resistance is independent of the frequency. Suppose if R is equal to 10 ohms, it will be constant throughout this. So R is constant. R is 20 means it will increase. It is constant. It is not depending on the frequency. Your resistance is not depending on the frequency. R is constant. Okay, this is the curve for the resistance. Now here in between I am taking a resonant frequency also. This is F0. Let us take resonant frequency, F0. F0 is the resonant frequency. Okay, now I am taking the curve for XL minus XC. We have drawn the curve for, Z I had to draw. I had drawn the curve for R. I had drawn the curve for XL. I had drawn the curve for XC. Now I will draw the curve for Z. Now I will draw the curve for this Z. And tell me Z is equal to, Z square is equal to R square plus XL minus XC whole square. Z square is equal to real part square plus imaginary part square. Hypotenuse square is equal to side square plus side square. Now let us take F is equal to 0. First case I am taking F is equal to 0. If F is equal to, what is XL? What is
0.
XL? 0. What is XP?
Infinity.
Sorry, J is 0. Okay. J is 1 by X, 1 by 0. 1 by 0 is infinity. 1 by 0 is infinity. Okay. 1 by 0, sorry, here J is not there. Square we are taking, no? That's why J is, here J is there, sorry. R square plus XL minus XP whole square. Then Z is equal to R square plus minus infinity whole square. What is that? Infinity only. Okay. Now here, if you add infinity to anything, what is the value?
Infinity.
Infinity. Now Z is infinity. First case I am taking, when F is equal to 0, your Z is infinity. Okay. When at F is equal to 0, somewhere it is there. I am taking beyond this line, it is there. Infinity means beyond this. At 0, somewhere infinity, just like XC. Negative infinity, here positive infinity. Now take F is equal to F0. F is equal to F0. At F is equal to F0, what is the condition? At resonant frequency, what is the condition? What is the resonant condition?
XL equal to XC.
XL is equal to XC. Substitute here, XL is equal to XC. What is this XL minus XC?
0.
0. Then what is Z?
R
Z
square.
is equal to R. Okay, Z is equal to R. Now come to the next case. Can I remove this F is equal to 0? Now I am substituting F is equal to infinity in this. Z square is equal to R square plus, when F is equal to infinity, what is XL? When F is equal to infinity,
Infinity.
XL is infinity. When F is equal to, it is 0. 1 by infinity is 0. Now what is Z?
Infinity.
Infinity. That means when F is equal to 0, at F is equal to 0, it is infinity. At F is equal to F0, what is the value? At F is equal to F0, what is Z? So it is varying from plus infinity to R. It is touching the R line. At F is equal to infinity, it is touching the R line. Again at F is equal to infinity, it is going to infinity. So this is the curve. This is the curve. At F is equal to 0, it is infinity. At F is equal to F0, Z is equal to R. It is touching the resistance line. This curve is touching the resistance line. Again at f is equal to infinity, it is going to infinity. When you increase the frequency to infinity, again it will go to infinity. This is the curve for Z. This is the curve for Z. Observe this. If you are having doubt, you can ask me. In these curves, what are the curves we have discussed? R, XL. This is XL. Your XL will go to infinity. Your XL will go to infinity. This is the curve for XL. This is the curve for XC. And this is the curve for Z. At f is equal to f naught, the value of Z is R. The value of Z is equal to R. It will vary from plus infinity to plus infinity. Any doubt in this curve? Okay. If you are not having doubts, we will go to our textbook. Okay, listen here. This is a series RLC circuit. Okay. See the curves. Observe the curves here. First XL curve is it. This is the XL curve, straight line. This is the XL curve, straight line. See your XC curve. This is 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 your resistance curve, straight line. This is your resistance. And what is Z? See Z, it is varying from plus infinity to, at f naught it is R. At resonant frequency it is R. Again it is varying to infinity. It is going to infinity. This is the curve for Z. This is the curve for Z. Now I want to draw the curve for current I. I want to draw the current for I. I want to draw the current for XL minus XC. See, I will draw the curve. Okay, now I will draw the curves for I. At f is equal to 0, what is Z? We got infinity. At f is equal to f naught, what is the value of Z?
R.
R. At f is equal to infinity, what is the value of Z? What is the value? See, we have
Infinity.
calculated infinity. It is infinity. So now I will calculate for current. F is equal to 0, Z is infinity. What is the formula for I? What is the formula for I?
V by Z.
V by Z. If Z is infinity, what is I? If Z is infinity, what is current?
0.
1 by infinity. V by
0.
infinity. 0.
0.
Okay, this is the first condition. So this is the first part. At f is equal to 0, your impedance is infinity, but your current is 0. See, your current is 0. Now take f is equal to f naught. F is equal to f naught. Z is equal to R. I is equal to V by R. I is equal to V by R. Next I am taking at f is equal to infinity. Sorry, at f is equal to infinity, your Z is infinity. If Z is infinity, what is the current? What is the current?
0.
0. Now see the current variation. At f is equal to 0, current is 0. Here current is 0 I am keeping. At f is equal to f naught, I is equal to, impedance is minimum. Then current will be, here R is minimum. Then current will be minimum or maximum. See, this is the minimum point. At f is equal to f naught, current is, impedance is coming to minimum value. Impedance is minimum. If impedance is minimum, if R is minimum, what is the current?
Maximum.
Current will be maximum. Write down here, current is minimum. Impedance is minimum, current will be maximum. I will take the maximum current here. At f is equal to f naught, I will take the maximum current. This is the maximum current. So it is varying from 0 to maximum. Current is varying from 0 to maximum. Now again at f is equal to infinity, what is the value?
0. I equal to 0.
0. Again it is 0. It will come to 0. At infinity, when f is equal to infinity, it will come to 0. At f is equal to 0, your current is 0. At f is equal to f naught, impedance is minimum, but current will be maximum. This is the maximum current. Let us take, this is the IM. IM is the maximum current. IM is equal to I naught. I naught is the resonant current. At resonant frequency, we are getting the maximum current, I naught. IM is the maximum current. I naught is maximum current. At resonant frequency f naught, I am taking it as I naught. I naught is equal to peak value, maximum value, peak current. Again at f is equal to infinity, your current is coming to 0. At infinity point, your current will come to 0. This is the current curve. This is your current curve. If you are having doubt in the current curve, you can ask me. This is the maximum value, I naught. I naught means at f naught. At f naught, your current is I naught. At f naught, your current is I naught. Okay, impedance will be minimum. Your Z is minimum. This is your Z. Z is minimum, current will be maximum. Because current is inversely proportional to Z. Current is inversely proportional to Z. Now I have drawn the curve for current also. Now I will draw the curve for XL minus XC. I will draw the curve for XL minus XC. Take F is equal to 0. When F is 0, XL is omega L, XC is 1 by omega C. When F is 0, XL is 0. 1 by 0, infinity. What is the value of XL minus XC? XL is 0. When F is 0, XL is 0. XC is 1 by 0. 1 by 0 is infinity. Minus infinity, please. Now take F is equal to F naught. At F is equal to F naught, what is the value of XL minus XC? What is the condition at resonant frequency?
XL equals to X.
If XL is equal to XC, what is this value?
0. 0.
Okay. If XL is equal to XC, the difference of this is 0. So at F is equal to F naught, your XL minus XC is 0. At F is equal to 0, your XL minus XC is minus infinity. Now take F is equal to infinity. At infinity, frequency is infinity. That is, XL is infinity. Here 1 by infinity is 0. 1 by infinity is 0. Your XL minus XC value is infinity. That means what is the variation from 0 to infinity? From 0 to infinity, how the XL minus XC is varying?
Minus infinity to infinity.
Minus infinity to 0 at resonant frequency. Again from 0 to
Infinity.
infinity. Minus infinity to 0, 0 to infinity. Now start from 0, F is equal to 0. Minus infinity is here. Minus infinity to, at F naught, what is the value? 0.
0.
Minus infinity to 0. Again from 0 to, it will go to infinity. It will go to plus infinity. Is this graph clear? XL minus
Yes,
XC.
sir.
This is XL minus XC. Okay. Now we have completed the graphs. Now observe the diagram. I am showing the diagram. See here. This is XL. XL is this linearly it is raising. XL. Then XC. See, XC is varying from minus infinity to 0. XC. Then Z. Sorry, R. This is R. Resistance is constant. Resistance is independent of frequency. Then Z. This is your Z. Inverse of Z is I. This is current I. See current from 0 to again in maximum. At F0 it is maximum. At resonant frequency, F0 is the resonant frequency. At resonant frequency, current is maximum. Again it is coming to 0. This is the current. Current is inversely proportional to Z. Current is inversely proportional to Z. Then XL minus XC, you see, X is equal to XL minus XC. It is varying from minus infinity to 0. From 0 to infinity. See, minus infinity to 0, from 0 to infinity. This is the resonance curves. In exam, you have to write all these curves, then only they'll give 5 marks. This is the compulsory question in exam, university exam, to draw the resonant curves. They won't ask resonant curves, explain resonance. Explain resonance. Then you have to draw the RLC circuit, then you have to write the condition for XL resonance, XL is equal to XC. Then you have to derive F0. F0 is equal to 1 by 2 pi root LC. F0 is equal to 1 by 2 pi root LC. Then we have to draw all these curves. Only curves you draw. There is no need to give the explanation. XL is equal to omega L, F is equal to 0, F is equal to F0, F is equal to infinity. All this explanation not needed. Only you draw the curves. For your understanding purpose, I have written all these things. F is equal to 0, F is equal to F0, F is equal to infinity. All these things there is no need to write in the exam. Exam, draw only the curves and mention the curves. What is XL, what is XC curve, what is Z curve. You have to denote with the letters Z, I, XL minus XC like this. Okay, that's all about the resonance explanation. Next we will go to the next topic, that is, remember the Z curve and I curve. Next slide heading, determination of upper and lower half power frequencies. Right on the side heading, determination of upper and lower half power frequencies. Determination of upper and lower half power frequencies. Side heading, this one. Right on the side heading. Determination of upper and lower half power frequencies. Upper and lower half power frequencies. We'll draw this curve. I'll write on the board. See here, x-axis frequency, y-axis current, y-axis current. Already had, this is 0. Let us take, this is F0. Let us take, this is F0. At F0 you will get maximum current. At F0 I will get the maximum current. Because impedance is minimum. At F0 your impedance is minimum, current will be maximum. I am taking at F0, I am taking it as I0. I0 is the maximum value. I0 is the maximum value. Now here, This is the maximum value. What is the RMS value? What is the formula in full wave rectifier? RMS value is equal to IRMS is equal to I think you remember this formula in full wave rectifier.
Yes, sir.
Okay. IRMS is equal to IM by root 2. IRMS is equal to IM by root 2. Now take this is IM, peak value. That is I0 by root 2. I0 by root 2. 1 by root 2, what is the value? What is the value of 1 by root 2? One by root 2 value. Can anyone tell?
Zero point
0.70.
0.707 I0. Now here this is 1 into I0. 0.7 means it will be here. 0. This is the value of I0 by root 2. This is the value of I0 by root 2. I am taking it as F1. F1. I am taking this as F2. F1 and F2 are, F1 is the lower cutoff frequency, F2 is the upper cutoff frequency. F1 is lower cutoff frequency, F2 is upper cutoff frequency. I am taking the RMS value here. This is the RMS current, IRMS. IRMS is equal to I0 by root 2. This line is touching the curve at 2 points. One is this point and this point. F1 is called lower cutoff frequency. F2 is called upper cutoff frequency. F0 is the resonant frequency, peak value. You will get peak value at resonant frequency. Then I am defining bandwidth. Bandwidth is equal to F2 minus F1. Bandwidth is equal to F2 minus F1. Right on? Bandwidth is equal to F2 minus F1. Okay. Now I will determine the power at this frequency and at this frequency. What is the power P? P1, P is equal to I square into R. What is I? RMS current or what is that?
RMS.
RMS. What is the RMS current you have here?
I0 by
I0 by root 2. I0 by root 2 whole square into R. That is equal to I0 square into R by 2. What is the maximum at resonant frequency? What is the power? At resonant frequency, what is the power? What is the current here at resonant frequency?
I0.
I0. I0 square into R. But P is the power at F1 comma F2. This P is the power at F1 and F2. P is the power at F1 and F2. P0 is at resonant frequency. At F1 and F2, your power is half of the resonant power. That is P0 by 2. Power at F1 and F2 is equal to this power divided by 2. Is it okay?
Yes, sir.
P0 by 2. Power at cutoff at F1 and F2 is power at the resonant frequency by 2. Okay, now see here. Okay, listen here. Half power bandwidth, the resonance circuit. See, power P1 is equal to P2. P1 is the power at F1. P2 is the power at F2. How much you are getting? Power at resonance by 2. This is power at resonance by 2. So up to here, right? In tomorrow's class, I will discuss the remaining things. Okay. Now I'm stopping the class. I'm having one meeting. Okay. I will stop. I will note the roll numbers. Who are absent? Can anyone tell? Six is present. 6 and 10. 6 is present.
Is present, sir.
Okay. 10.
Absent, sir.
Absent.
Okay. 10. 11, 12, 13. 13 is absent. 10, 13. 15.
So 13 is present, sir. 15 is absent.
Okay. 13 present. Okay. 10 is absent. 15.
Absent, sir.
15 absent. 18, 19. 18, 19 absent. Next, 23.
Sir, 23 got power cut, sir.
Okay, no problem then. I will give attendance. Next, who else option? 34
Absent.
absent. Okay, I'm telling the absent is reason 10, 15, 18, 19, 34.
Yes, sir.
Okay, I'm stopping the class here. Tomorrow I'll discuss the remaining things.
Sir, 10 present, sir.
10 present, okay. I'll give attendance to 10. Okay, now we can exit.